Okay, now the last talk in this track for today. The speaker is from the Netherlands and works as an IT consultant for Deltax. And the talk or the presentation is about SNMP, and it explains us SNMP is simple and understandable, so that we're experts, hopefully, after the talk. So the speaker is Rob Hessing. A warm welcome, please.
Okay, thank you.
Oh.
Well, first of all, thank you all for joining. My name is Rob Hessing. I am from the Netherlands. I work for a company called Deltax. Deltax is a system integrator. We do a lot of IT stuff. Actually, we do NetApp, HPE Aruba, VMware, Microsoft. Almost everything you can imagine what you can do in IT, we try to do it, or we do it. We also Nagios reseller, so I'm sure it's not too popular over here, I've heard, but okay. Oh yeah, Deltax, 60 colleagues, and we're based in the eastern part of the Netherlands, so near the German border. I'll try not to mix up my languages because I'm still thinking Dutch, speaking German all day, and now doing my talk in English, so it's maybe a bit difficult. I'm an IT consultant at Deltax, a hardworking IT consultant. I do monitoring and networking over there, mostly wireless, and for monitoring we use Nagios at least 25 of our customers where we maintain the entire environment for them. During the weekends, I like to drive my 2CV and go to meetings and looking for a bit more adventure. So. SNMP. Why should we use SNMP? Well, one of the main things, it's simple and it's a network management protocol. It's highly available because a lot of vendors support it. So if you want to look at switches or a Windows machine or a Linux machine or whatever, you can use SNMP to ask things from the system and see what the current status is. So supported by most vendors, and most importantly for us, there's no third-party software needed. The problem is we maintain a lot of networks from our customers, and the customers don't want us to install extra software on their machines, but they still want them monitored. So our solution was to use SNMP so we can still look at the different things we need to know from the systems, if they're still working okay, or if a hard drive runs full, or if memory is overloaded. So I'll get a bit more technical and a bit more into depth how it works. It's using UDP, ports 161 for asking stuff from the system, from the device, and 162 for SNMP trapping. SNMP trapping, I'll explain that later, how it works. It has an SNMP header, and that contains the SNMP version, and a community, at least in version 1 and 2C, and a PDU type. PDU type is what do we want to know? What do we want to do to the system? Do we want to get one piece of information or a lot of information? But I'll explain that later as well. There are 3 versions available for SNMP. SNMP version 1, still usable, but 2C has a bit more well, you can get more from SNMP version 2C. And version 3 is also available. It supports encryption, which is for security reasons maybe a better choice. But it also gives us some overhead and therefore harder to configure and not very often used as far as I can see. So we have a network monitoring system, and we want to check an Ethernet port on a router. So check the interface status. We send a GET request to the router and get a reply back from the router saying that it's up. This is just one very simple example. On the other hand, we can also configure the router to send an SNMP trap once Ethernet interface, the internet interface goes down. It sends a trap to the network monitoring system, and the network monitoring system then can handle it. But I'll get into depth about that later. Now we're going to be a bit more in depth for the protocol. The SNMP protocol, it has a community string, which is actually some sort of password to get the information from the system. You can get a read-only community string or a read-write community string. And then we've got these PDUs, and that we can say what we want to get from the system. So do we want to get just one piece of information, and then it sends a response, but I'll show it in my Wireshark. I don't think this is readable, but I've zoomed in a little bit. Here we see the protocol. This is version 2C that is used. The community in this case is public. It's not really secure, but we see that it's sending a GET request, and there's an OID over there. And the OID, I'll explain later how that's built up and what it does. In this case, the OID is get me the, I think the contact from this system. An answer is sent back. You also see it's, again, version 2C, it's public, it's the GET response in this case. And we see over there that it's my name for the contact person for this system. The OID is a bunch of numbers, but it's built up pretty good, and I'll try to explain it. All OIDs start with this sequence, so 1361, and after that it's split up into in a different tree. Mostly used is the management and the private. First, I'll start with the management. If something is really common, it's always in the management MIB files. And things like interfaces, the most common things, contact persons, is all in the management MIB files. So the OID then would be 1361211, and then the next thing you want to ask. There's an entire tree underneath it. The private part, this is for enterprises. So all major enterprises can get their own OID number. I've put in some examples here, like Cisco, Microsoft, Apple. But most bigger companies have their own OID, so they can write their own MIB files and then therefore can get really specific information from their own systems. Well, this is the path in the OID tree. In this example, we want to get the system contact, like I did in my Wireshark example. And the OID is then the 136121140. And if we go back, we can see it goes up here, 1, and then 14 for the syscontact. And the system name is the 5 and the syslocation. And so we can get the entire information from the remote system. But we can also use a shorter method to write it, and then we just ask for syscontact. So it knows that it needs all the stuff in front, and we can just, when we do an SNMP get, we can just ask for syscontact, and then it will get the information as well. MIB files. It's not the man in black. It's actually, the MIB file is like what DNS is to an IP address. These OIDs are very hard to read. You can't remember them. So in the MIB file, they explain how of what is available for a certain OID. These OIDs explain what type of information of variables we can get. So if we get, for example, the uptime, it will be more like a timestamp. And if we want to get the system contact, it would be a string, a display string or a normal string. So there are different types of information.
Sorry, can you move a little bit into the pictures just for the recording, so you're that you're on the video. Thank you. Sorry.
Okay. No problem. It's standardized, of course, and then in the MIB files also described the access. Some parts are not accessible. There are tables, and I'll explain them later. These are not directly accessible, but the OIDs underneath these tables are accessible, and they can be read-only or read-write. A read-only example would be system uptime, because you don't want to write your own system uptime. But the system contact, of course, is a read-write thing, because you can change your system contact just by putting an SNMP set, and without logging in and changing config files, you can use SNMP to change it. In the MIB file also described a status. Most all the OIDs have a current status. It can be current, absolute, or deprecated. Deprecated means that it's in there just for backwards compatibility. For example, disk sizes could be written in counter 32 at first, and later on they changed it to counter 64 because the output was getting bigger and bigger, and it didn't fit in the counter 32 anymore. So they left in the counter 32 just for backwards compatibility, but they also added then the counter 64, and then in the MIB file it's described as a deprecated OID. These can still be used, but well, maybe you should check if there's another OID which is better for what you want to ask. In the MIB file is also a description, and the description will tell you what the output can be and what it actually does. So what are you asking for, and it's well described this way. This is an example for a MIB file. We have here the system uptime, which has a syntax in time ticks. As I said, read-only, of course. Well, status is current, and the description says the time in hundredths of seconds since the network management portion of the system was last reinitialized. So with this OID, you can ask for this uptime for the system, and the syscontact is a display string up to 255 characters. It's read-write, of course, and it gives you the contact information from the sysadmin or whatever you want to put in there. And as you can see, we have this has a description and all the information you need. That way you can check if that what you want to check is available, and you can browse through the MIB files, and I'll show you later how that's easily done. I'm sorry.
The colons and the equals?
These. Well, that's just part of the MIB file. So it's not something I've written. It's how the MIB file is set up, and this is the last part of the OID. So if you have this 1361 blah blah blah, and then it ends with 3. So it's in the system. Well, you remember the OID 3, then it goes to management, and then system, and then it's the number 3 from system. We also have devices with multiple things, like for this example, this is a NAS, or at least a storage device, which has a lot of hard disks. And if we want to check with SNMP how that's set up, they don't have a single OID for every hard drive, but they put up a table, and this table is filled with information about all storage systems in this device. So in this example, I'll show you about a storage device. I do an SNMP walk with my very secret community string to an IP address, and I'll ask for all storage devices. Then instead of getting just one thing back, I'll get a table back. And this table is set up with an index, and then what all different kinds of information about this single device. As you can imagine, this is an example for storage, but for a network device, it's exactly the same for the interfaces. You'll have an index with the number of interfaces, and then you'll have speed and the admin status, upper status, all different kinds of things you want to know about one single interface. In this example, we have 5 storage devices, and it creates a unique index number for each device. So if we want to get information about just one device, we can ask for just the information that ends with 4, and then I'll show it in the next example. One thing you have to notice is that it never ends with a 0, because it's a table. It ends always with the index number, and in the example where we ask for the system uptime, it ends with a null, 0. So it's this 0 indicates that it's just one single piece of information, and with a number at the end, it indicates that it's a table. Well, here I wanted to ask about the root petition. This device had a root petition, and it had the index number 4. So the bold part is the thing I really want to know. So you see its root, and you see its block size, and its storage size. So if we want to ask the system how big the hard drive is, we end up with getting the size times blocks allocation units, or block size, and then divide it a couple of times by 1024, and then we know how much gigabytes this hard drive is. And we also know what the system's usage was, because it also tells us here how much is used, and then you can subtract it and know how how much data is on this hard drive. This is the part from a MIB file where it explains the table. This is the storage entry, and as you can see, it's not accessible because the table itself has no information. It's the different OIDs that give us the information about the different devices in the system. Is that clear? Okay, tools. We need tools to check what we, build our checks or check what how our system is doing. And we've got different things. We've got the CLI. We can do an SNMP get. We tell it what version, the community string, the IP address, and we want to get the syscontact. Quite simple. It gives us back the information, what's in there. In the example I given before, it was my email address. An SNMP walk, then you get a bunch of information. So you get, well, actually the entire tree, what's available at that moment for this system, which can be pretty much. An SNMP set. As you can see, I've written a different community string, a very secret community string. This is the read-write community string then, because we can make a differentiation between a read-write and a read-only community string. And then we can set the information. In this case, we set the syscontact. We know it's a string, and the string is knock@deltax.nl instead of my personal name. I prefer to have my colleagues also have a look. Another nice tool we can use is SNMP netstat, which can be very handy if, for example, somebody with a Windows machine says, well, I've got this web server set up, but it's not working. You have to open the firewall, and you do a netstat, and you see nothing is listening on port 80 or 443. Then you know, okay, he's not correct. The web server is not set up correctly, and then you can go back to them. Another great tool I've been using a lot is the iReasoning MIB browser. This is a bit zoomed in. It's this part of the screen. In this case, I've chosen to look at the interfaces, and as you can see, the interfaces also have a table. And in this table, we have, of course, the index, which is a unique number, and then the description, the type, MTU size, speed, and there's a lot of information for every interface on this system. And the fun part is, if we check at the description and what is in the MIB file, we can see the upper status, which is actually the current status of this interface. It has its own OID, which then can end with a dot, and then the number of the interface you want to know something about. So with an Ethernet 1, this probably is a 1 for the first interface. It sends back an integer, so it actually doesn't send back its up or down. It sends back a 1, and this 1 is then represented for up. And so we have all these different things we can get back from the system. In this case, it's quite simple. We have an up and down. But if you want to check, for example, the defense status from a switch, it also sends back a 1 or 2. And when it just gives back this integer, you don't know what it is. But in the MIB file, it explains what it is. And with the MIB browser, the iReasoning MIB browser, you can then actually see what status you can get back and what then how your script would look like. Okay, a bit more about trapping. An SNMP trap is sent by a device when a status change occurs. This can be, for example, a printer running out of paper. It's a very simple example. Maybe you don't want to monitor that, but also the uplink status from your switches, from your routers, which can be quite important. It's a single UDP package sent on port 162. It's sent to the system, to the network monitoring system. The problem with that is it's just an OID. So it's again this bunch of numbers or a really cryptic description what is sent out. And it's configured in the SNMP trap daemon config in a normal Linux system. So on your network management system, you'll have SNMP trap daemon configured. You say it's authenticated by a community, it logs everything, and it executes the trap handle for some community strings it's also checking. In this case, the community string is public, so the system sends out a SNMP trap, and the trap handle, by default, is sending it to SNMP TT, which is a trap translator. But I'll get into depth about that, because we need something to understand it. I've chosen for the Babelfish, so it's like everything that talks to us, we can understand it, and we know what it means. The SNMP trap translator. It makes the traps more human readable. So, for example, if an uplink goes down, we can get this big OID string, and SNMP TT knows how to deal with it and knows what this OID means, and then translates it for us to a human readable thing. Or All the actions are defined in the config file, and we can use these MIB files, which I already given the examples for, to create these config files. I'll give an example how that goes. And we can use the SNMP TT convert MIB, which then converts the MIB to a SNMP TT config file. We can use SNMP TT convert MIB. We put in a MIB file. In this case, I've chosen the Aruba trap MIB file, which describes all the traps that can be sent by, in this case, it's the Aruba controller for wireless. And we have an output file we call snmptt.aruba. And we also give a execute with that. I'll send all my information to a shell file, snmp trap sh. And then a lot of things come behind. The $R is for the host name. So the host name that sends out the trap is put in here by the $R. This is my service description. This is the default status I'm giving to all of my SNMP traps to start with, because I prefer to make sure that I know what's for me critical and a warning state, for example. This gives the entire description, so all the variables. This is a timestamp, and this is the description from the that is in the MIB file, so the description I showed before. So yeah, this will convert all the traps defined in this MIB file, and this snmptt Aruba file is put in the snmptt.ini file, and then it's checked for the OIDs that it's receiving. So for every OID it's receiving, it will check all the config files defined in the snmptt config. And if it's there, then it will handle the, will start this script. Script is quite simple. First we have the $1 host name, because the $R was my host name. And here it checks the host name. I've given a default description for the service check. In my case, it was SNMP trap. $3 is the state string, so it's OK, warning, critical, or unknown. And all this information I send back to, using NSCA, to my Nagios environment. But I'm sure it can be used in Insinga as well, or Zabbix, or every other tool. Then we can choose whether we want to get an alert or not. So in my example, all the SNMP traps are at first are OK, and I'll check the log files and see what's for me critical and where I want to be woken up at night for. So, for example, an uplink, OK, I'm OK to wake up for when an uplink goes down, but I don't want to be awake for something very simple, like my management logging in with SSH to download a config file or stuff like that. So how I set it up, Ethernet interface goes down, the SNMP trap is sent to the network monitoring system. It gets a completely unreadable OID. So I've got no idea what this means. I'll send it to my shell script, and what it does, it says, well, this is for a network interface that goes down. Sending out the service description, network interface, critical, and I send the link is down. In my SNMP trap shell, I'll send everything via NSCA to my Nagios environment. And then in my Nagios environment, I get here the information about the traps I received. In this case, I've got two different passive checks. One is the normal SNMP trap, which receives all the traps from for this switch, all the regular checks, all the other regular traps, and I've differentiated the interface traps for the up-down status to a different check, so I can see the differentiation. The thing was, if a network interface goes down, this check will be critical, and if that's critical and you log in with SSH, which is also generates an SNMP trap, it can become okay again, because you think logging in with SSH is okay, or warning, or, well, at least not critical. So I had colleagues logging in with SSH into the router, checking the interface, but then checking Nagios again and say, well, okay, the alert is cleared, so it's not critical anymore. But the interface was still down because there's a new SNMP trap sent, and it's overriding the last status. Okay, that's it for now. Are there any questions?
Have you considered using an alternative to the SNMP trap daemon like Logstash or something? Something else that can collect SNMP traps?
I had a look at the Nagios thing, the SNSTI, I think it's called. But no, I haven't used any log thing, what you mentioned, no. The SNMP trap translator works great for us, so because we have the MIB files from our vendors, and when we install a storage device, it's 9 out of 10 are NetApp, so I know exactly what I can expect from the systems, and all our switches and wireless environment is all HPE Aruba, so that makes it a bit more easy to reuse these MIB files and reuse the config files.
Okay, thank you.
I'm also using Ansible then to distribute these config files and make sure it's maintained, and it's for all the customers the same.
So if I buy any equipment like a switch, how do I get the MIB file? From the website of the vendor? Or?
Most vendors have them on their websites, yes. And there are also a couple of nice web pages to have a look at, which show you the... well, I can see if I can get it up. Sorry for my background. I'll try to hide it as quickly as possible. Oh, I have no internet, of course.
Okay.
Yeah, well, the website is called oidview.com, and it gives an overview of all the MIB files available. Well, they're not all on there, but at least you can get an overview from the enterprise OIDs, and you can search by name and search by OID number. So if you get information back with an SNMP string, you can check the OID number for this enterprise, and then you can see which vendor it comes from and see if there's a MIB file available then.
And the community strings, can you change them?
Yes, of course.
And you are changing them at your equipment, or?
Yeah, so we've got all, for all our customers, we have a different community string.
So
and
I think this is something we should remember when coming back. So looking for the community strings of our equipment and changing it, perhaps, because I wouldn't like somebody grab my SNMP interface.
It's quite dangerous then, yeah. If it's default switched on and it's still public, then you can get a lot of information about the system. So at least you know on which ports it can listen, you know how it's configured. Even if you only have the read-only community string, you can get a lot of information about the system.
Okay.
So, do you know any debug tools or anything else for broken MIBs? Because if they are not able to be translated, especially like Avaya, oftentimes.
Are the MIB files broken then? Or
Right. They're, with a SNMP converts, they are not able to be translated.
okay. Ooh. Well, normally you get some debug information from the convert MIB, and well, then it's really hacking into this file and changing it by hand. But it's not very easy to be done. But I've done it before because we had one vendor which also had a broken MIB file, and I knew which OIDs I wanted to check, so I've written the MIB file just for them, or for us actually, and to use it and be able to use the MIB file instead of just the OID. But yeah, then you're really into hacking MIB files, which is not fun.
Okay, thanks.
All the times I touched SNMP, many times I had problems where to put the MIB file, because I always followed how-to or something, but still it didn't work. So maybe you can share your experiences where you need to put the MIB file to get those easy names when you do the SNMP walk.
You put the MIB in a Linux system. Normally CentOS puts them in user share SNMP MIBs, and actually you put the MIB files on your network monitoring system. So not on a remote device, but on a device where you want to do the translation. And if you think they're not picking up these MIB files, you can put in a -m, a small m, and then capital ALL, that it reads all the MIB files that are available on that system. And you can also put your MIB files in your home directory in a certain path. I'm not sure where that goes, but that's also a possibility.
You told us about the different versions of SNMP, V2, C, and 3. And I have some customers who tell me they have the policy from the security guys that tell them they are only allowed to use V3. So is that even doable by now, or what do you think?
It's doable, but yeah, like I said, it's giving you extra overhead, and it's pretty hard to configure sometimes. And you still have a username password, which is then of course encrypted, but yeah, I'm not a big fan. And I don't see it used that much. Then I would prefer to put my information in a management network instead of just setting up a secure layer on my public network. But yeah, that's a choice you have to make. And one other thing is, if you set up SNMP, you can tell it only allows you to accept queries from the network management system, which then also narrows it down. Then you'll have to do IP spoofing and stuff like that before you can misuse it. So yeah, I don't think it's that big a deal in a normal network environment, because then somebody's already hacking your network.
Okay, thank you.
Welcome.
Just about a note about SNMP v3. We are using that wherever it's possible, but we also have headache with that. The main headache we have is that in SNMP version 3 you have so-called engine IDs, and the net SNMP driver, or libraries which are in the Linux, are from the year 2012 or something like that. There are missing really things. For example, if you reboot a system which is connected from a server with SNMP version 3, then the cache of the engine ID and the password and the hashes are still there, and you are not able to connect the device again until you empty the cache which is a command which is not available, or you reboot the system, the server.
Okay.
This is, for example, one of the things we face quite often as a problem with version 3.
Yeah. Okay. Well, thank you for sharing.
Okay.
No further questions?
I think that was it. So thank you very much for your talk, Rob.
Thank you. Thank you all for joining.